All right, this is number 15 from section 3.7. This is a proof, and it uses some of the concepts that we have just been talking about. So let's get to it. We look at what's given and we put it in the picture. So that's what I'm going to do first. So HK is congruent to JM. Okay, and already, now that I'm looking at that, I'm thinking subtraction property or something along those lines, because I could subtract JK from both segments. But let's see what we're going to use that for. All right, GJ is congruent to JK. So GJ is congruent to JK. OK is congruent to JK. So we're going to mark them all with one tick mark because they're all the same. And GJ and OK are both perpendicular to HM. Okay, so I need to say that. I know that's going to make right angles, but I'll need to say that somewhere later on in the proof. So the first thing is always just the given, and at least write the given one time. All right, since my given's right here, I'm not going to rewrite it. I'm just going to put the quotes. All right, so write it one time when you're doing your proofs. All right, so let's see what we're trying to prove. We're trying to prove FHM, the big triangle, is an isosceles triangle. So there's a few ways you could, there's actually two ways you could prove something's isosceles. You can either prove that two sides are congruent, or you can prove two angles are congruent. So what it looks like I'm going to have to do is it looks like I'm going to have to prove these little triangles on the side, GJH and OKM triangles, congruent. Because if you can do that, you can prove that that big triangle is isosceles by proving that the base angles are congruent. So let's see if we can do that. So looking at this proof, first thing, and basically I'm not given anything in both of those triangles, in triangle GJH and triangle OKM. So what I have to do is come up with stuff. So the first thing I'm going to say is that based off the transitive property, that GJ is congruent to OK. That was never explicitly said, but it's kind of that chain. Since GJ is congruent to JK, and then JK is congruent to OK, the transitive property tells me that GJ and OK are congruent. So I need to say that. So there's one side in those little two triangles. I'm also given that HK is congruent to JM. And like I said when we started, that's the subtraction property. So right away, I could say HJ is congruent to KM by subtraction. Because if the same segment is subtracted from congruent segments, so the same segment being JK, subtracted from congruent segments HK and JM, the differences are congruent. So there's another side. All right, so lastly, I can prove the angles, and I'm trying to prove the right angles. I'm given perpendicular. That doesn't prove congruence, that proves right angles. So what I need to say is angle GJH and angle OKM are right angles, because if perpendicular lines, then right angles. And then I need to say, based off the fact that they're both right angles, now I can say they're congruent. So I can't just jump right in and say that they're congruent because they're perpendicular. I need to take these couple steps, and this seems like a formality, but that's kind of what it is. So if I got two right angles, then they're congruent. So that's what I got. So I got these two angles are congruent. I proved that HJ was congruent to KM. And now I'm ready to prove that the two triangles are congruent, the two little side triangles. So there's an angle. Okay, and again, if you're given perpendicular lines, you need to take two steps to prove you have congruent right angles. Okay, so now I can say triangle GJH is congruent to triangle OKM by side angle side. And now I want to prove that the big triangle is isosceles, so what I'm going to say is angle H is congruent to angle M. Yes, DPCTC, or corresponding parts of congruent triangles are congruent. And now I can say that the big triangle FHM is isosceles, because if base angle is congruent, then the triangle is isosceles. Okay? So that's a 8-step proof to prove that that triangle is isosceles, and it uses a lot of properties: perpendicular lines, subtraction property, transitive property, proving triangles congruent, CPCTC, and the idea that isosceles triangles have base angles congruent. So hopefully that helps you complete problem 15 from section 3.7.